right. Can everyone see my screen? Or at least someone say that they can see my screen?
Yeah, you're good, Professor.
Great. All right. So as we talked about, this is chapter 6, updating data. Just a reminder, we're actually more than halfway through the class. In fact, I suspect that this week is when I do the 60% review of participation. So just make sure you're getting your homework in. Make sure you're taking your quizzes that will qualify you for participation. If you're concerned about that and want to be marked present in that 60%, please shoot me an email, talk to me about things, and we can see what we can do. So when it comes to creating a new table from an existing table, this actually can happen more often than one would expect. And we'll talk about that here in a little bit on why you might do this, especially when it comes to altering tables, why you may need to do this. So when we want to create a new table, and we already have a table, we can do some things to kind of take that data and put it into the new table. We're going to use the create table command, just as we would expect to, as well as we're going to now use a select command with an insert command to take the data from the old table and put it into the new table. Now remember, I'm using a older slide deck than what you have online because it incorporates these screenshots. While this is an older version of Oracle Application Express, the UI is quite a bit different in our current Apex, but the contents of the queries are going to be the same. So I like that they have these little screenshots so we can actually see example queries and talk about them. In this, we have an example where we're creating a table, level 1 customer. So that table is going to be called level 1 customer. And then we're going to have a customer number character char 3, which is the primary key, as well as the customer number char 35, a balanced decimal, a credit limit decimal, and then a rep char 2. Now you can see that this table structure will replicate the existing table structure that we are duplicating from. Because of that, we can go ahead and we can say insert into level 1 customers, select customer number, customer name, balance, credit limit, rep number. If we go back to this, we can see that that follows this list of columns. And again, if you are changing up your columns from the original table, then you definitely have to make sure you use the select statement with the column names in the order that it's going to be in the new table. And we're pulling it from the customers table. So all this data that is in the customer table, we're going to now insert into this level 1 customer. And why would we do that? Well, one way is to make a subset of data, and this is what we're doing in this example. We're pulling all the data where the credit limit equals $7,500. So obviously that's going to be our new level 1 customer. Now, with that being said, we can also change existing data in the table. This is a very common thing to do. Oftentimes, we consider a application, one of the core components of developing a software application is that it can retrieve and update data. Now, yes, you can have an application that just reads data. There are plenty of those, but most people really consider the ability to update data as a core component. So how do we do that? Well, some more keywords for us to use. We're going to use the word update with the name of the table to be updated. And we're going to set the name of the columns to be updated and equals new value. Now, this is a little bit different than what we did with insert, but it's very similar, and we're going to see some similarities there. We can also do a calculation on the fly when we're doing an update. So here is us doing that update level 1 customer. And we're going to set the customer name equals unique gifts and toys, where customer number equals 796. Now with that being said, before we go any further, I want to take a moment and pull this off the screen. And the query that we just looked at says update level 1 customer, set customer name equals unique gifts and toys. Where customer name the reason why I wanted to take a moment and talk about this is this where clause in this query is significantly important. If we were to comment this line out, so all we have is update and set, nothing different's going to happen when we hit run versus the full query. So doing just these 2 lines versus the 3 lines, nothing different's going to happen when we hit run, as in no message is going to come up and say, hey, are you sure about this? Are you wanting to do this? And the reason why I say that is because the full query with the customer name will only update technically 1 row, right? We're expecting only 1 row of data to be updated because we're looking for 796. Now, if we didn't know any better and the customer name was allowed to be duplicated, then, customer num, you're probably all sitting there going, it should be num. 796. If we didn't have this, if we didn't know any better, we could say that customer number isn't a unique field, but we know that it is, so it's not a big deal. We know because it's a unique field that this full query together without the commented code would only update 1 record. Whereas just these 2 lines will update every record in the table. And that's pretty big. In fact, it's something to think about here in a moment when we start talking about some transactions and rollback, because it could be a very simple mistake to run just this query by itself, which will update every row in this table to have the customer name unique gifts and toys, versus this where it only updates 1 row. So be careful when you're typing in your queries. Make sure that you double check what you're about to run, because sometimes you're going to do changes that you can't come back. And if you didn't have a backup of this data and you ran this query, you might be in quite a bit of trouble. That's not what I want. I'm looking for my inventory, right? There we go. All right. So this has what's known as a simple condition, and we're going to update that 1 row. In this, we have a compound condition. So now we're saying, hey, set that credit limit in that level 1 customer to 8,000, where the rep number equals 45, but also the balance is greater than 2,000. Again, just want to make sure I point out balance is greater than 2,000, which means 2,000 will not work. If the balance is 2,000, the record will not be updated, because this by itself, using just the greater than sign, is not inclusive. So 2,000 would not render as true in this where clause. The reason why I wanted to bring that up is as I'm going through and grading papers, one thing I did kind of see is people are using the words, the keyword between. Remember that between is always inclusive. It will include the values on both sides. And so if your existing problem is not looking for an inclusive result, the between is going to not be the right solution. Now, yes, let's say that the problem says, give me everyone that's between 25 and 75, and that field happens to be an int. So we know that 25, the next number has to be 26. There is no in between. It's not a float. It's not any of those things. So we could say between 26 and 74, but to be frank with everyone, that's just bad styling, because you are now changing what the requirements were from everything between these two numbers exclusive and not inclusively exclusively, and you're actually changing the requirements now to read between 76 and 74 inclusively. Why could that be a problem? Well, maybe down the road when we are lifting the database and we're making changes to it, let's say we change it to a float, we will think that the between, or this can be to a decimal field, we'll think that the between statement is accurate when at this point it's no longer accurate, because if we change that column from an int to a decimal, then 25.01 would be greater than 25. So it would make the cut. All right, that was a little side note. So as we're adding new rows to an existing table, we always use the insert command to add additional data, and we use the select command to verify rows were added correctly. This is oftentimes a missed piece. I also will tell people, when you do an update, you should always do the select command as well, just to make sure everything was done as you expected. Again, imagine if you did this query without that where clause. If you don't test your work and you go running off, you may have just messed up an entire table, brought an entire system to its knees, and not even realize it until someone in your support system is raising all kinds of severity 1 tickets. So we want to make sure we're being careful. So like the update, we're going to do the column value respectively. The difference is in this case we have to where we don't list out the column names, and so because we're not listing out the column names in this example, the system will expect that you give a value for every column in the table and in order of its column order. So that's why we said insert into level 1 customer the values, and these columns will directly match up with the columns that we listed way back when we created this table. Now, real quick, because this is the right place to do it, we said in our query, insert into level 1 customer values 907 Now, just in case I didn't say it, but I'm pretty sure I did, and just to reiterate it, whenever you have a single quote in your data, you have to do what's known as escaping that character. And in SQL, it's rather easy. You just do you do not a double quote, but you do 2 single quotes. The first single quote tells the system that the second single quote that's coming behind it is actually in the data and to list it in that data. So what we see here with this double quote really will, in the database, if we were to look at the database later, it will give us just 1 single quote in that data. If we don't do the double single quotes, then you'll either get an error or data will be left off because it thinks you're closing your string. This was the query that we had. And that's a great query. But what if we didn't need all that data? What if we didn't need to put in a rep number? And let's say that the rep number allows for null. Well, we can do that by using set and listing out the column names. And again, we decided that we're not going to add the rep number, so we're going to take that out for the moment. And again, we are pretending that the rep number column allows for nulls. And because I want to do that, as you can see, I've now created this set and I've listed out the columns that I'm going to fill data with. And I left that last one off, the rep number, because I don't want to put data in there. I want it to be null. So that's how you would do it, is you use this set and this values. Now, please understand that, again, some of this doesn't ring true anymore with the online Apex. If you installed Apex on your machine, if you installed Oracle on your machine, depending on what version you installed, this will be in the UI or not. But for example, the auto commit is a default transaction mode, and we're about to see a screenshot where you can turn auto commit on and off. As we know, or as hopefully you've seen, auto commit is no longer a part of our checkboxes up here in this top column, or this top area. We're about to see a screenshot where that is exactly how it exists. And it just doesn't exist that way anymore. In fact, you don't have in Apex, the newer versions, you don't even have the ability to turn off auto commit. I have tried everything. I've looked things up. I have done queries and tried queries, and I have not found a way to turn off the auto commit anymore. And I suspect a lot of that is because that role has been removed from users that are using online Apex. Multi-user database applications require more control over transactions. And that's where the commit and rollback come in. So what is auto commit, and rollback? When we talk about auto commit, when we run a query, like we've been doing, we actually haven't ran them, but let's say we had run this. If the auto commit is checked, then the system automatically makes that update. There is no ifs, ands, or buts. It's done. It's over. We move on. Like I said, we in the older versions and installed version of Oracle, you can turn the auto commit off. So when you run these queries, it's as if you are sitting in a transact, and at some point you have to commit that transaction. So that's all I wanted to talk about when it comes to auto commit, is that there is this concept of it. Most people aren't using it anyways, mainly because we don't need to. We mean to auto commit all of our queries when we're doing single queries like we've been doing, but that's what auto commit is. And when it comes to commit, it's that save changes immediately during current sessions. So we're going to see commit being used in some other fashions, but in this case, what they're saying is because in their older version you could turn off auto commit, you would actually have to issue the commit command to save those changes. You could view things, you could write a query, and then view things as they are going to be once you commit. So that way, if you didn't like it, you can then use the rollback command, it would roll it back, or you could use the commit and make it actually happen. So Patty, you have your hand up?
Yeah. So the book mentioned that you don't want to use the auto commit when you have multiple people in the database. Like, is it last shot fired, or why is that?
So the reason why they're suggesting you don't use auto commit when you have multiple queries, and I want to make sure that that's what you're talking about, is when you have multiple queries, not to use the auto commit, correct?
I thought it said multiple users, but maybe it did say multiple queries.
Again, I'd have to go look at that. I can tell you why not to use auto commit when it comes to multiple queries is you can quickly run into just issues that occurred, let's say in your first or second query, but in the third and fourth you've already ran, so you've now even more complicated data. It's harder to manually roll things back, and so that's why you want to very much avoid doing auto commit. In fact, it's one of the reasons why when we're getting into more complex, and I believe it's either the second to last or the very last week, we'll actually write some stored procedures. We want to use commits and rollbacks and transactions, because we want to allow all these things to happen kind of in this temporary state to make sure everything happens as it's supposed to, and then commit those changes. And what that means is, I've seen it. I've actually seen this happen, actually more than once, where something goes wrong right in the middle of your store procedure, or right in the middle of your multiple query item, and your data gets not inserted or updated, or something doesn't go right, and then or this, I've seen where literally the power has gone off on a database in the middle of a script, and only half of the item gets committed because it's auto committing. Now you have corrupt data because that stored procedure or that script was meant to run as a total package, and now only half of that package is run, and more than likely you may not even know that only half of that package is run. So that's why you want to be careful. Now, I can immediately think of another reason why, and maybe the book is saying multiple user, is again, the reason why you got to be careful with multiple users when it comes to auto commits is you and someone else may go and try to change the same row of data on the same table at the same time, or rather very closely. And because of that, you accidentally change a record that it's not supposed to be. Or I think a more complex solution, if we were using an update that utilizes current data in another table, and our update is going in and trying to compare data over this table to this table and update things, and then someone comes along while you're doing that and runs a query that changes the data you're looking at, you just could see a lot of you could see a lot of problems that could occur. If you don't auto commit, you have that ability to first look at the data you just changed, make sure it is what you want, and then commit. Hopefully that answered your question.
Yeah, thank you.
Yeah, I got a question. So in this process, isn't it wiser to generate the SQL input file and then pull a backup copy of your database and then run it on the backup in case anything goes wrong, and then once you know that it's okay, go ahead and copy the now revised version over the old?
So that could be a method that someone might want to use. I can tell you plenty of reasons why that wouldn't be a good method. If your table is huge, if your query is going to update a lot of data, if you are talking about a real-time system that that lapse of update would actually affect data to and from your customer, would be another reason. And that's also just a lot of work when there are definitely more efficient ways of doing it, like I said, with the transaction commit and rollback.
Okay, thank you.
But yeah, you could do that. That would solve this problem for sure. I will tell you, if I am developing something, and especially if I'm having to just for whatever reason, because we've got a huge production issue. Someone's losing millions of dollars per minute because of their system being down. It's not unheard of to get into a production environment and debug and try to find where issues are occurring right there in production, because you're trying to minimize impact, right? And so there's a great example of where I'll demand someone pull a backup first before I start touching it. So, there's plenty of reasons to do the backup method for sure. All right, so that rollback command only reverses changes made to data. The commit command is permanent, so running rollback after commit cannot reverse the update. It seems logical. I'm not sure why they had to feel the need to put that in the book, but that is the case. And see that also as part of the auto commit. If auto commit is turned on, which it usually is, once it's auto committed, you cannot use rollback to reverse the update. All that conversation really is pushing us towards this topic, which is known as a transaction. When you are getting into database development, if you are going down that path, if you are making stored procedures, most likely transactions are going to become the thing for you, right? We want to make sure that we're grouping data pieces together in units of work. And sometimes those units of works are sequential steps of data that we want to accomplish as one single task. Imagine you are creating a invoice for a customer. You don't want to start adding rows of data that they've put in their shopping cart that they're wanting to purchase. And I apologize. Let's say that they actually hit the purchase button. Now we're actually moving that data into an actual receipt. We don't want to get half of that data in there, and then the next call is actually to look at that data we just put in there to come up with the total and then charge them. If we did that as single transactions, every query is its own transaction, one of those transactions could go wrong, and we would do things down the road that we wouldn't want to do as one unit of work, right? So for example, for some reason, while we're inserting these rows of information into their bot database or the receipt database or the transaction database, table, we, for whatever reason, something burps in the system and we only get half of their cart into this table. If we then use that table to do the addition to find out how much we need to charge them, we want the system to stop and say, oh, we have not been able to successfully do this piece of query, so do not do the rest of these queries. Instead, roll back data and notify the user something went wrong. That's what a transaction can help us do. The piece that you have to remember with the transaction is at the end, you either have to commit it or you have to roll it back. So with transactions, before you start updates for a transaction, you want to commit any previous updates. And that's again, because if you don't, you could run into issues where previous data just didn't get updated. Your current data is looking towards those committed changes and they're not there. So it's good to make sure that you've committed any previous updates. When you get into store procedures, that's not really a big deal because you're just you're working on this one unit of work, so it's not really a big deal. You want to complete the updates for the transaction. So you're going to write this transaction. You're going to start this transaction, and essentially you're going to go through and do query after query as part of this unit of work. And if at some point something can't be completed, you're going to use the rollback command to roll everything back, no harm, no foul. Your store procedure probably would issue an error to somebody, hopefully, that can, utilize and make use of that error. However, if everything gets through and there's no errors that are coming back from anything, then you can use that commit to say, okay, everything's good. We made it through all these queries. No errors are in the queue. Go ahead and commit this as a complete transaction. by the way, for those. She has joined us today. One of my puppies has decided that she wants to be part of the lecture. So this is, she keeps coming in and out of the background. Her name's Riley, and she is a mini Aussie and wants to be part of the class. SPC should charge her. All right. Changing and deleting existing rows. Again, they're going to make this auto comment is turned off, commit, excuse me. And this is where they're doing this. They're doing this update. They're setting the customer where the customer number is, but because the auto commit's turned off, it's not actually executing that piece of information. We can then view things, to see what it would look like, but at the end, we have to actually say whether we want to commit or roll back. Now, when it comes to changing and deleting existing rows, we can use the delete command to delete data from databases. Now, let's take a moment to think about this. I will tell you, in my experience, that most organizations will forbid you from deleting data. The worst thing you can do to any data is get rid of it. Then it's non-existent. We can never use it again. We can never have it. As well as, usually when you get a somewhat, even a medium complexity database, you start getting data that with foreign keys and all this, that is, it needs the data, it needs other data in your database to live off of. And so what happens is, if you start going and deleting data, you may have data that is tightly coupled with other data, and now you've deleted a row that it now won't be able to look up or find or what have you. For example, you may have a user table, and you are a membership store where you have to have a membership to buy things. And this user's come along, and now they said they no longer want to be a user. And you go and delete them from your user table. Right off the bat, I would say you just lost a lot of opportunity. Down the road, what if we ever decided we want to do a campaign to try to go after people that have left us and now we want to come back? You delete that data, we have no more access to that. So don't delete that data. Also, they've bought stuff along the way. So we have data in other tables that exist and is connected to that user. More than likely, we didn't duplicate that user's information into those other tables. We actually have a key that goes back to the user table that says, look up this user if you want more information. In fact, when we actually set up primary keys and foreign keys, and we start linking tables together, you won't even be allowed to use delete, because delete is smart enough to go, hey, this data correlates to this other data. We have constraints on this data, so you can't delete it. So just bear with us. We're going to do some deletes in our homework, and we're going to understand what the delete is, especially if you are working on data that you are just mocking up or testing or what have you, and delete command might be functional, but for the most part, you won't delete data. And so just keep that in mind. And when you get into the industry, be careful. I would never recommend you ever recommending to delete data. It's just a bad form. It's a bad thing to do. It's really cheap now to buy space to store data. So there's I'll have to think of it. There is I want to say it's, I forget the name of it. There's a documentary that talks about how in the 70s and 80s, we were just gathering tons and tons of data. We didn't know what to do with it. We had no clue why we wanted to gather this data. And then all of a sudden, starting around 2000 and higher, all of a sudden we started finding ways to model data and to start making use of this tons of data we have. And Facebook is actually a good example of using data that just was collected without any knowledge of why we'd ever want to use it. And now we're using it. So delete's just kind of a bad thought process.
Yeah, I got a comment.
Sure.
I just actually had that case where I had Uber and Lyft on my smartphone at one point, and then somebody got a ride on my phone number somehow, and I ended up having to pay for the ride. So I uninstalled them both. But when I went back now to check it on Lyft, and I reloaded the app, all I did was put my phone number in, and all of a sudden all the data was there. And I didn't like that. To me, that's not kosher. And then so I had to go through and jump through a lot of hoops to get them to commit to deleting my data from Lyft. But they also said that it's in accordance with, they're deleting it in accordance with certain laws. So I don't know how those laws do or don't apply to the database management component.
Yeah, and more than likely, they didn't delete your data. Now, maybe they did because they have an agreement with you. But what I'll say is, even though we don't have, or we don't like the idea of deleting data, we have ways to simulate deleting data. One way is to add a column, like for your users table. I will always add a column called active, and I will turn that flag to 1 if they are a current user. If I want to delete that user, I would set that flag to 0. And then my system knows to treat that data as if it were deleted, but it's not truly deleted. And if I ever needed to do now a history lookup on something that this user might have done in the past, but no longer is with us, I don't have now concurrency errors and all kinds of weirdness happening in my data. I still get the data just like I would. I might put in the code to flag that in the UI, make that row maybe red or something like that, so I know that user has been deleted. Here's the data, but just so you know, the user's been deleted, kind of thing. But that's typically how a lot of companies are going to do it. Is they're going to have some kind of flag column to say whether a piece of row is quote unquote deleted versus an active row.
Yeah, well, in my case with Lyft, they had my credit card information, and there was no way to actually, for me to get rid of the credit card information and still keep the account open, because you have to have a credit card in order on file in order to have the account. So
Right.
That's why I went to delete it.
Right. And again, just from a database perspective, I would have just marked your row as inactive, and I probably would have gone into the credit card table, and I would have just zeroed out your number or something along those lines. So the data, all the other relevant data is still there and marked as virtually deleted, but not deleted, right? But again, I don't know what they're, some companies do have, I know Facebook has got this policy where there is a way for you to actually get them to delete your data. But it's pretty devastating to the Facebook infrastructure. So like when you go this route, it deletes you, but it deletes like, all the posts that you've been a part of. It's crazy. And I believe you have to have like a court, you have to get a court order to do it. I don't know. Anyways, but just that's the understand is coming out of this conversation is that for the most part, deletes just really aren't true deletes because we want to keep data. Our systems rely on data, even if it's meant to be deleted, it still needs it for historicals and stuff like that. So delete's just not a very common thing. All right. And again, this is another cautionary statement. All rows satisfying the condition will be deleted in your where clause. Guess what? If you forget to add the where clause, it's going to delete all your rows. And it's not going to ask you ahead of time, hey, are you sure? It just doesn't work that way. SQL is raw and very functional. And so it's not going to ask you whether you meant to delete all those rows or not. I strongly recommend that you do a select statement with your where clause first to really view the data you're about to delete, and then substitute out the select pieces with the delete pieces, so you know what you're deleting. So here we said delete from level 1 customer where customer number equals 893. I would have done a select first just to make sure that a select star from the level 1, that this is truly 893 is the row I want to delete. Once it's gone, it's gone. In this case, we are showing how, now that we've done that delete, that 893, because the auto commit's turned off, that we're doing a select star to check, and we found that we didn't like that piece. And so now we're doing a rollback, and then the deleted row will be reinserted for us. Again, because we don't really have the auto commit, it doesn't mean a whole lot other than this is similar to what happens in a transaction. Kind of a little weird side note here. If you're wanting to change a value in a column to null, you would do it just as normal, except that the value that you're going to use is the word null, all in caps. So we can say update that level 1 customer, set balance equals null, where customer number equals 665. And that null, that capital null, the system knows to delete the data associated with that particular column.
So can you explain that? I mean, null actually takes the digital place of the previous balance.
So remember, null is not like 0. It actually is the absence of data. So when you actually set the balance equals null, depending on what system you're using, behind the scenes, it may just set a pointer to no data. It may maybe in the background just references the fact that this is now null data, which is 0x0. Whatever it's doing behind the scenes, it's telling the database engine that that particular row and column has no data. It's not that it's 0 data, it's actually truly no data. Because in this case, for example, balance equals 0 and balance equals null are two very distinctly different statements. Did that answer your question?
Yeah, it does, but I guess the critical component is that if you're replacing a balance on a specific customer, that you need to make sure you're doing it on the correct customer as well. So you would add the select in this case?
I would do a select first. Yeah, absolutely.
Okay. All right. Thank you.
Yep. All right. Here's another place where I will tell you. So changing a table structure, right? They make it sound super simple to change a table structure. And for all intents and purposes, it can be very simple. But the reality is it usually is not this simple. We're going to learn how to do it with the simple way of doing it. But I will tell you, if you get into more advanced SQL, that's where you'll learn that most of the time table structures just cannot easily be changed. And because of that, there's more advanced ways to do it. So just kind of keep that in mind, put it in the back of your head, know that this is not as, that this does work, but usually on pretty simple data. So when we change a table structure, we're going to add new tables. We're going to delete tables no longer required. We're going to add new columns to a table, and we're going to change physical characteristics of existing columns. So believe it or not, changing a table structure is adding new tables and deleting tables. But what we're really talking about is how do we add new columns to a table, or how do we change the physical characteristics of an existing column? To do that, we're going to utilize some new keywords, alter table. Alter is a keyword to get familiar with. It does mean to alter or to edit something, because you're going to use you're going to use the keyword alter in quite a number of things. In this case, we're altering a table, so we're going to use the alter table command. And we're going to use the add clause to add a new column. We can also assign values to this new column, and oftentimes the simplest approach is to give it a null. Or you can use an update command after the fact. So you can add your column and let it be null, and then come back after the fact and use an update command to change all the rows to a more common value. We can also use it to obviously change individual rows too. So here we have this alter table level 1 customer. We're adding customer type char1. So we're adding a new column named customer type, and it's going to be a char1 value. Now we're going to say update level 1 customer, and we're going to set that customer type to equals R. Why did we pick R? Well, obviously, behind the scenes, somebody has some kind of schema that says R should be this. Maybe it's C is another common customer type, or so maybe R is residential and C is commercial. I don't know necessarily what the schema behind the scenes is. And by the way, it's also another reason why oftentimes we don't go this route when it comes to these kind of lookup values. Oftentimes we would have another table that has the customer types in it. So 1 equals residential, 2 equals customer, so forth and so on. So we could always look that pieces of information up in the database, or we can do joins and join the friendly name back to the customer type. But in this case, they know what R stands for, so they're setting the customer type to R. Why do they pick R? Because most likely R is the most common customer type, and that means they will have to change less rows by hand to whatever the other customer types are, because R is going to be the significant, or the most rows will have R. Here we're doing a one-off where we're saying update that a row in the level 1 customer where the customer number equals 334. Let's go ahead and set that customer type to an S. If we describe the table, we can see that we've added that last customer type, and we made it a char1. Now we can tell the system to make it to where it's not nullable, but if we do that, then in our query that is creating column, we actually have to fill the data as well. We can use the modify clause of the alter table to change those characteristics of an existing column. So we have a table, let's say we want to change this customer type. Now that we've added it, we want to change this from a char with 1 level, or one length of 1. Maybe we want to change it to the number like we've been talking about, where we use a lookup. We can use that modify to do so. We can change a column that currently rejects null values. So oftentimes we will, out of the gate, make a column nullable, fill in data as required, and now change that that column to not be nullable. So we'll use null in place of not null, or vice versa. We can also increase and decrease the size of a column. So here's an example where we're saying alter table level 1 customer, and we're modifying the credit limit to make it not null. So now from here on out, you cannot have null data in there. This will error out if you already have data filled in your table, and the credit limit, one of the rows has a null in the credit limit area. This will not run. It will throw an error. The error also is not very intuitive, just FYI. So if you go to do the not null and you get an error, more than likely that's what's going on, is you've got a null somewhere in the data you're trying to turn to not null. You definitely can make complex changes. Changes to a table structure may go beyond the capabilities of SQL. We just kind of talked about this. If you want to start eliminating multiple columns, changing column orders, combining data from 2 columns, the way to do that is you have to create a new table. So essentially, you're going to create a new table in the with the schema that you now want. You're going to then write a query that's going to take all that data, move it from the one table into the new table doing any kind of changes or massaging of the data as needed when you're putting it into the new table. And then when you're done with that, then you want to permanently remove the table of the original table and all of its data from the database. That's really important. And a lot of people don't follow through with that. And now you have these tables that are just sitting out there with data. It's becoming stale. When a couple years down the road, when you hire a new database programmer to come on, they start looking at your schema and they're like, what is this table? And everyone's forgotten what that table was. And so yeah, just make sure when you are doing these changes, clean up while you're there. To drop a table, we've already seen this in, when we were talking about scripts. Scripts. Actually, before we finish this, hold on a second. I don't know if we have a whole lot of. No, we're almost done actually with the. So we're going to finish up our lecture here, and then we'll take a break, and we'll come back and talk about homework. So when it comes to dropping a table, you can use the drop table. We've already talked about that from previous examples back when we were talking about running scripts. And when you use the drop table, it will permanently remove the table and all its data from the database. On occasion, you'll go to drop a table, you're going to get an error, and that can happen if you've got constraints. So if you set up a constraint from one table to the table you're dropping, it may not like that you're trying to drop it because you're going to break the constraint, and it will give you an error instead of dropping the table. And here's an example of how to drop a table. Drop table level 1 underscore customer. So that is all the information we want to cover in chapter 6. That will give you a great start on the homework. So let's go ahead and take a 15-minute break. And when we come back, we will go ahead and jump into some homework examples and then take any questions that may come up out of that. And then we will be wrapping up the night. So let's go ahead and meet back about 7:15. Thanks, everyone. All right, it is 7:15. Hopefully we can get started here. And we're going to go over a few of the assignment problems for this week.
Okay, so I got a question. This week is that 60% that you were talking about in the beginning of the semester?
I believe so, yes. Okay. Any other questions? All right. So let's go ahead and jump into number 1. Give me a second here to get my screen sharing. So number 1. It says create a paddling table with the structure shown in figure 6-29. So if we look at the little table that they have, they've got a few things here for us to make sure we take note of. But the trip ID is a decimal. That's pretty unique for a primary ID field, but it is a primary key field, so we're going to make sure we put that in there. We've got a trip name. It's got a width of 75 and a state with a width of 2, as well as a distance that's also a decimal, and the max group size also a decimal, and the season being char 20. Now, interesting enough, even though they are decimals, they have 0 decimal places, so in effect we're making integers. So how does that look? What will that look like? Well, we're going to use our new keywords, create table, and we are going to give it the name that they've requested, which is paddling. We don't need any kind of quotes around that. We've got a column named trip ID. It's a type of decimal with 3 characters wide and no positions for decimal. And it is our primary key. We also have trip name. And this is a char column that is 75 characters wide. Then we have state. This is also a char. And then we have distance, which is a decimal. 4 wide, no decimal places. Then the max group size, also a decimal, also 4 wide and 0 points. And then season, which is a char 20 characters wide. Kind of look that over, make sure it looks good. It does. So let's go ahead and run that. And there is our table created. Now we can, if we want, just go ahead just highlight that one line of code, and there is our new paddling table. And it meets up with exactly what we were expecting. And that is number 1. Any questions about 1? Okay, we'll move on to number 2. So in this, we're going to insert into that paddling table that we just created the trip ID, the trip name, the state, distance, max group size, and season from the trip table for only those trips having type paddling. Okay, so it makes sense now what we're doing. We're trying to create this table that's designed for just paddling. So we're going to say insert into paddling. We're going to select trip ID, trip name, state and distance, and max group size and season. From trip where type, we could do like, or in this case, we're just going to go ahead and do the equal sign. And because this is technically a subquery, I usually like to indent and put parentheses around it. You don't have to do that in this case. It would work without it. But I like doing that because that, again, helps just the next person coming along to read this a little bit better. We can make sure we have everything in the correct order. We do. Let's go ahead and run that. Again, just to check our work. Now, there we go. Just FYI, just so you all know, I like that the book did not have you add the type to this new table because we don't need to, because obviously the type of this table, everything that's going to be in this table is going to be for the paddling type. So why have that data twice, right? We know the table's about that, so why have that as a column too? All right, any questions about that? Okay. I think we're cooking with steam. All right. So now we're going to delete the trip in the paddling table with the trip ID 23. And this, by the way, is number 5. For all those playing at home. This one's relatively easy. But I wanted to do this one because this is how I would do this problem. I would first say select from.
Question.
Yes.
So the one we just did, was that number 2 or number 3?
Number 2.
2. Okay. Thank you.
Yep. Select from paddling where trip ID equals 23. And then run this. Oh, sorry. Yep. Sure enough, that is exactly the one I want to delete. So now you can either just change it. I tend to, because I like to keep track of the things I'm doing. And then I'm just going to change this, say delete. Make sure I go ahead and run just that statement. Statement processed. If I now do the select statement again, no data found. Exactly what I would expect. I'd also, just because I'm a little bit on the cautionary side, I would select start from paddling as well, run that, make sure I still have data. Yep. I didn't do anything bad, because again, if I said just that statement, that would be pretty bad. All right. Any questions about that? Okay, we're going to look at number 8 next. So 8 says, change the difficulty _ level column in the paddling table to HRD for the Lake Champagne Tour tip. Actually, let me take a look at this. I think this actually requires that we did something before that. It does. It actually requires us to do number 7. So we'll go ahead and just do that as well, number 7, which is add to the paddling table a new character column named difficulty level that is 3 characters in length, then set the difficulty, the default difficulty level value for all rows to the valid MOD. So part 1, we're going to do alter table paddling. We're going to add difficulty level, and we're going to add it as a char with 3 characters wide. we're going to go ahead and do part 2 as well. We're going to update paddling, set difficulty level equal mod. Now, these are 2 queries. And again, I can run them together, or should be able to run them together. Just make sure. No, it's not going to like it because it doesn't want to. It doesn't want to do the auto commit on with the multiple queries. So we'll have to do just the first part. So there's the table altered, and then we're going to add, or excuse me, update the table to show to change the difficulty level column to mod. And then because I want to make sure I am checking everything, testing everything, I will do that. Go ahead and run it. Make sure that, yep, all of them are mod. Great. And then number 8 was that change the difficulty level column in the padding table to HRD for the Lake Champion tour trip. So we're going to update paddling. We're going to set. Wants to change it for me. That's funny. Set difficulty level equals HRD where trip name equals Lake Now, this is exactly why I like to do select statements first. So what we're going to do is we're going to come down here and we're just going to say select star. We're going to highlight this piece of query and hit run. Oh no, what happened? Oh, well, that's because I didn't. Run it. We're getting no data found. So this is a good reason why oftentimes I'll do select statements first before the actual update, because I want to make sure I'm doing it correctly. I'm updating the right row. I'm not messing my data up. And again, I obviously have something misspelled here. So let's try this. CHAMPPLAINTOUR. Okay. So then let's just go back and run just this. It must have maybe somewhere before this it wanted us to. No, it shouldn't have. And maybe there was an insert that was in one of the previous assignment to do this, to add this row. I think so. That's why it's not here for us. But that's okay. We can change it.
Yeah, it's number 4, Professor.
Okay. So then let's just go ahead and for the sake of this, we're going to just pick a different trip name. But again, that's a good example of why doing a select statement first is always helpful, because I was able to, before I tried to update and really get into the thick of why this wasn't working, I was able to quickly use select statements to get to the bottom of it. So we're going to do this. We're going to check to make sure we have that row. We do. Now we can just go up here, comment that piece out. We can go ahead and hit run again. Should update. If we don't highlight these 2 hyphens to say comment, if we highlight from there on out, it will ignore the comment when I hit run. And there we can see that it changed it to HRD like we expected. Again, just for those that are watching this, I picked Mason's Farm only because the lake tour is not, we had to add that as number 4 in the assignment. We didn't do that piece, so I just picked a different trip. But that way you can at least still see how to do it. And then finally, anyone have any questions about that? Sorry about that. Okay, so number 11 is the next one we're going to do. And this simply kind of resets us and takes us back to 0. Delete the paddling table from the database. This is a pretty quick and easy one. We're going to use the drop table command that we've learned with paddling. Oh, before we do that, again, let's make sure this is really the table we want to delete. Yeah, I made that change and it's ridiculous. So now that I've done that, I can go ahead and just get rid of all that and run this as a query. There you go. So that's number 11. Any questions about that? So hopefully that's a good helper to the homework. There's a couple of other things you'll do in that homework. The critical thinking is there, and it definitely is expecting that you use some internet research for other data types. So make sure you do some Googling and figure that out, and then you should be all set to go for this week's homework. Any questions about the material we just covered? All right. Anyone want to? I'm sorry.
So you're going to release the video fairly soon this time, because it came in actually pretty late this week.
Yep. Just as I said at the beginning of the class, I will be able to render this and get it up faster than I did last week.
Okay. Thank you. I appreciate that.
Yep.
Good night.
Good night. All right. Anyone want to cover any questions with previous stuff, or anything else? Any other questions that aren't necessarily related to this?
I have one, Professor. So last week's homework, there was like 3 questions where it referenced the examples from the chapter. We didn't have the tables to run those queries. So I ended up just kind of like recreating the same example with our tables. Is that going to count against me?
Can you tell me which numbers you're talking about?
Yeah, hold on one second.
Sure.
So number 7 was 1, number 9 was 1. And I think that was it.
Okay, so, and we're talking about chapter 5, correct?
Yes, sir.
All right, so it says repeat exercise 6, but this time use the exist operator in your query. So in that one, you would just utilize the query you came up with for 6 in the previous, the previous number, but you're going to use the exist operator in your query instead.
Well, so it says exercise 6, right? So I took it as like the actual exercise from the chapter.
Oh, I understand. Yeah, I apologize that because what it meant was you're doing number 7, so use what you did, the work you did in number 6, and now do that, but use the exist operator in your query.
Okay.
If you want some extra time for that misunderstanding, just shoot me a message and let me know.
Will do.
Yep. Any other questions?
Yes, I just wanted to find out if it's still okay to turn in the extra credit to make up for the week 2 assignment.
It sure is. It sure is. Yep.
Okay. And it's just to do the towel, I think.
Solmeris.
The Solmeris. Thank you.
Yep.
Okay.
And just email that to me.
Okay. Thank you.
Yep.
So on that, we're just doing the Solmeris questions, right? We're not using the Solmeris database for the TOR questions.
So for number 2, remember we haven't, for that chapter, we had not installed the database yet. That is all manual work. It's all normalizing data.
Correct, but the questions at the back of the book for the Solaris questions or the tour guide questions?
No.
I guess try and confuse you.
Yeah, so for chapter 2, if you had a hard time with the colonial, you can go back and redo that chapter and submit for that chapter the Solmeris exercise questions.
Okay. That's, yeah, you answered it because I was trying to answer the colonial questions with the
Gotcha.
Solmeris, but you want to answer the 3 questions that are on the Solmeris in the book.
Correct.
Okay.
Yeah.
All right, cool. And then I have another quick question for you on the course homework for each week. Are you aware that like the discussions are going into the next week's chapter?
I'm not aware of that. I will take a look at that and check it and see what's going on about
Yeah,
that.
I wasn't, I mean, because the previous weeks they've been in reference to the current chapter, but like this week's it was answering chapter 5 was about commits and auto commit.
Oh, that's interesting. Yeah, let me go ahead and check that and make sure that's supposed to be like that in the line correctly.
Okay, and the same thing with this week. The question for this week is referencing something in next week's chapter.
Okay, I'll check on that.
Cool, thank you.
All right, anyone else have any questions? Okay, so just a recap for those that may have not heard me at the beginning. Everything should be like normal next week on Monday. I should be here giving the class live like we expect. There is a slight chance though, however, because I am moving, that the internet people do not follow through on their commitment, which never happens. As long as I've been on this earth, they have always nailed their appointments. So says the professor sarcastically. So if that were to happen, I mean, I do have a hotspot. I just don't know how well it'll handle doing a live video. So there is a chance. Make sure before you come to class, just check out and make sure that I haven't posted a news article or a news like the announcement, or I haven't sent you an email saying that the class is being suspended. If I don't have a class, I will post online a lecture that goes over the material and should definitely fill in everything you need. But hopefully we'll be here and live as we're supposed to be. All right. Unless anyone has any questions, I'll go ahead and let you all get back to your evening and shoot me messages as you need it.
Have a great
Great,
night.
and enjoy moving day.
Oh yeah, definitely. I'm excited. Actually, I really am excited because I'm going from this small little place with no garage to now I have a garage again. So I'm actually really excited. So
Excellent. Have fun.
all right, thanks everyone. Have a
Thanks,
good
bye.
one. Okay, bye.